Good afternoon, everybody. My name is Matthias. I will present right now about ecosystem of a Linux distribution and what's under the hood. So, first of all, thank you for all the sponsors to help to make this event happen. A short outline, so I will talk really shortly about me. Then we will talk about what is a distribution, a Linux distribution in general, what it is made of, what different types of Linux distributions does exist. Then we will talk about package, how to create packages, and the package system, how it works, how you actually build the Linux distribution image, and then how you test the distribution. And in the end, hopefully we have some time for questions. Okay, about me. I'm a Linux kernel engineer. I work for SUSE. I work for ARM64 at SUSE. So I'm contributing to SUSE as my work and as my hobby. And I used to use Ubuntu as a distribution before I started at SUSE. So I'm not a radical of any kind that this is the best distribution. They're just different ones, and I want to explain a bit how they work under the hood. So first of all, I want to know who of you is using Linux distribution at work or at home, and who is not using Ubuntu? Ah, well, not using Ubuntu. Okay. Oh, that means that. Yeah, it can be. Yeah, it can be. It can be. It was just curious because I think that Ubuntu is really what most of the people use. So there are many different Linux distributions. Ubuntu from Canonical, Fedora from Red Hat, OpenSUSE from SUSE, Debian, Arch Linux, Gentoo, which are like community distributions. And there are many more distributions out there. So there's a homepage, it's called DistroWatch, which lists 300 distributions. And there are, under the first 10, there are these names I've never heard of, like Manjaro or Antergos or whatever. And apart from that, there are derivatives of the major distributions. So you have, for example, Kubuntu, Xubuntu, or Linux Mint, I think, is also based on Ubuntu in the end. So what is a Linux distribution? So as you know, a Linux distribution is made out of open source projects, which can be the kernel, the X server, Windows Manager, applications. And the thing is that these open source projects, they all have their own pace, how they do their releases and how they do their updates. And the Linux distribution is in some kind and in some sense a photo of the ecosystem. So you take all these packages or all these projects and at a specific version, and then you integrate that all together and make it work. So for example, this is like an example. You can see I put here the GitHub cat. It can be whatever. So this represents open source projects, and then you see they have different releases, the application and the library. And then maybe they screw up the library in version 1.9. They changed something in the API so that this application can only use version 1.8, but maybe not 1.7 because there's something missing which is needed. Though you have to take care about this. And as I said, you do this by taking like a snapshot or a photo. And then you make sure that all these components play nicely with each other. So that means necessary versions of libraries, of interpreters like Python, and so on and so forth. And so Linux distribution, if you work for a Linux distribution, it's not so much about the code in most of the time, but it's about the programs. So a user expects that everything works. If you start your Firefox and it crashes, and then you say, this is a crap distribution, I will use a different one. So you have to be sure that all these things work fine. So we will come to this, especially when we talk about testing. So there are two different distribution concepts, which is the stable release and the rolling release. So the stable release is the traditional release that is around for a long time, which basically take a package, take all packages at a specific version, and then it does then the Linux distribution vendor does backporting bug fixes if you found any newer bugs, any severe bugs which are fixed in newer versions of the software, or some features you want to backport. And normally you use upstream first policy. It's not. I think it's not strictly used by all Linux distributions, but the OpenSUSE, we are really strict about this. That means if you find a bug in any package, in any program, you have to fix it in upstream first, and then you can do the backport to your distribution. The idea behind this is that first you contribute to the software you're using, which is nice and which is like it should be. And the other thing is, if you later do an update of the software, you get the fix for free already. So, and then in a stable release, normally you have a maintenance window, which might be 1 year, which might be 4 years, or half a year, where the distribution vendor cares about security and bug fixes and provides updates. Though in some sense this is a conservative approach, where you don't change a running system in the sense that you don't update to a newer version of a program, but you stay at the version and just fix problems. So stable releases, known ones is CentOS, which is a free version of Red Hat Linux Enterprise, Ubuntu, or OpenSUSE Leap, which is like the free version of SUSE Linux Enterprise. On the other hand, we have a rolling release. A rolling release take all the packages at the newest version, and then looks if everything's working. And if everything's working, it publishes the release. So you have all the feature enhancements that come for free from upstream. You have all bugs and security fixes as well. And if you're fast enough, you can do this maybe every day. You do an update, and then you get you are always sure that the security fixes are fixed in a timely manner. So you have the latest and greatest software. Examples are OpenSUSE Tumbleweed or Fedora Rawhide. I'm not sure. Anyone using Debian here? Debian test is a rolling release, or no? Okay. Okay, so you have the latest and greatest software, but you have the problem of stability and usability, because as the example I showed beforehand, there can be some problems that programs are not working. So the big question is, how do we test this, especially if we want to release every 2 days or every 3 days an update? And it's impossible to do this by hand, because you will need more time to test than when you already want to release. So if you can put in 10 people who start installing the system, and then I try Firefox, and then I try something else, and now I see Kmail is crashing. And so this is not feasible. So you need some automated solution, and we will come to this when we talk about testing. Okay, just a small picture of the OpenSUSE ecosystem. So we have the rolling release with more than 8,000 packages, which are developed by the community, which gets updated all the time. Actually, it's working that there is in the build server, we will talk about the build server afterwards, there's a project that's called OpenSUSE Factory, which really has always the newest software of everything. And then when it gets built, they take a snapshot, and if the snapshot passes all the tests, QA things are necessary, then it will get published, and you have a new version of Tumbleweed. On the other hand, you have the stable release, which is OpenSUSE Leap, which has a shared core system, which is a stable base system, which it shares with SUSE Linux Enterprise, which is the enterprise product of SUSE. That is this guy is where SUSE makes money with. All this is for free. And on top of that, you have 6,000 packages which are developed by the community. And for SUSE Linux Enterprise, the packages on top of the stable core are maintained by the SUSE developers, and it's like really conservative, so you can have for many years the same version of, I don't know, Apache server or whatever, and you don't update because this software runs in the data center, and you prefer to have a working old version of Apache than the newest version, which maybe you will need 2 days to fix it, to get your web server up again. So how to make money with a Linux distribution? So as I said, the distribution in general is for free. So you can download and install it. And the update comes with support and maintenance. So you normally have contract. If you, as a enterprise, you want to install some of the enterprise systems, you make a contract with SUSE or with Red Hat or with Canonical or whoever. And so they will support you if something is not working, and if something is really broken because there's a bug somewhere in some library or in the kernel, then the distribution vendor actually has people who are working all the time with the upstream community, so they know pretty well how the software is working and can in a timely manner provide you a fix. And apart from that, you get security fixes, which security bugs appear more often than we think about it. And especially in the Linux kernel area, there are some infrastructure where all the distributions decide when to publish a fix for a security bug so that everybody can fix the bug in a timely manner, and so mitigate any problems that this security bug could provoke. Okay, as I said already, Linux distribution is based on open source projects, and these are managed by packages. So I want to talk a bit of the package formats. So a package format helps to build and maintain the software, which lives in some Git repository, SVN repository, or wherever. And the two main package formats are RPM and DBM package. From what I've seen, there is no big difference in both of them. I know that Gentoo and Arc use different package formats, but I don't know anything about them. So I just know that they exist. So apart from that, most distributions use binary packages. That means normally if you install a package, you don't install the source code, but precompiled program, which you download from a server. Gentoo doesn't do this. You compile your program locally, so you better bring a lot of coffee and maybe something to read, because it can take quite some time. Apart from that, I'm not sure. Is anyone here a Gentoo user? Yeah? How do they do the bootstrap? Sorry? The bootstrap, I mean, you get some precompiled stuff to install a base system, right?
Yeah, correct. You have GCC and other program to start compiling GCC.
Yeah, okay. So I mean, you get a kernel, GCC, libc in this stuff, and then you start this, and then you start to download and compile everything.
Take a lot of time on old CPUs. 8 hours to compile Firefox.
Okay. So maybe don't drink all the time coffee. If not, you will get some head problems. Okay, the package format is metadata, which describes the package. So it describes information about the package, where you can find the source code if you want to download the source code, possible patches on top of the upstream code. So you take the version 4.8, and then in version 4.9 there is a bug fixed, so you can backport this, and then you put the packet, the patch into the RPM or into the Debian package so that it gets applied. So then it describes the dependencies of the packages. There's some information for the build system, and the source code normally comes as a tarball. So it's a bit, at least RPM is a bit ancient. I don't know about the other packages, but you have actually a tarball. You can see, here you can see there's an example of RPM. So you see the name of the program. This is a really stupid program, which is Hello World written in C, okay? You have the version, summary, which explains this, the license. Then you can find where you can download the tarball, yeah? This URL, which these are the variables of name and version and so on from up there. Then you have a patch because you maybe are not even possible to write hello world in the first place. And then you have these build requires, GCC and make. I will come back to this later. And then on the next slide, you can see the RPM spec file defines different steps to actually build the package. So you have a preparation step in this setup -q. What it does, it just unpacks the tarball, and then this applies the patch 0 we saw beforehand. And then you call make, and then you call make install, and you can have a changelog here. You can have this in the RPM file. I think Fedora does it like this. OpenSUSE has its own file apart where the changes get logged to. Okay, so we have the RPM dependencies, which are really important to in the end describe what do my package need to actually work. So first of all, you have the build requires, which means if I want to build this package on my machine, I need to have these packages installed. In our case, it was GCC and make, because the source code was had a make file which invokes GCC. So you need these two packages at least to really build this, but there can be libraries and whatever. Then there is a requires, which means if I install this package, then I also need to have these other packages required to be installed as well. And then there's recommends and suggests, which are weaker dependencies on an installed package. Normally, the recommended packages get installed automatically by the package manager. And the provides is a bit complicated. You can, in a spec file, you can build more than one package in a spec file, and then to fulfill requirements for other packages, you can set a provide. In my package, and I provide foo, and then another package which requires foo knows that it needs to install this package. Also, it is not called foo. Okay, more or less clear. Okay, so we can see here, apart from that, we have application 1.2 requires library 1.8. It also requires GCC 7, for example, because it has some magic compiler flags which are only in GCC 7. So to manage all these, we have the package managers. In SUSE it's called zipper, in Fedora it's called yum, in Ubuntu it's called apt. And what they basically do, they resolve the dependencies. So you have all these dependencies of the packages, and then maybe the packages it depends on also has dependencies. So they create a dependency tree and calculate what you really need to install if you want to install one package. And apart from that, it manage package repositories, because packages are normally installed on a repository on a remote server. So you can put in, it's like a configuration file where you put in a URL where you can find packages, and then you can put in your own repository where you have your latest and greatest software, and then you can install it easily with the package manager. And of course, lots of colors and buttons. So if you don't like the command line, you can use normally a package manager as also a GUI to do this in a graphical manner. Okay, now we go from packages to a distribution. So as I said, packages get normally precompiled and published on a remote server. So this is called a build system, and it's some kind like a Jenkins, but it's normally it's a really old software because it was written long ago, and it's really crucial for any Linux distribution vendor, so they don't want to change it. So what they do is they build the packages in a change environment, which can be a change root or a virtual machine. And in the case of OpenSUSE, it's a virtual machine. So you start a virtual machine, and then you install base packages, which you say I will need in any case. And then you install all the packages of build required on top of this. And then afterwards, you start to actually compile the package. So normally you can build the same package for different architectures. You can build it for Intel, for ARM, for PowerPC. And the package have a revision number. For example, if you add a new patch to the package, then the package gets a new, the revision number gets increased, so that later if someone says, hey, my Firefox crashes, and then you can have a look what version of Firefox and what revision does he install, and maybe you added already a fixed version that no, you have to update first before I will open a bug for you. And you can collaborate on to update packages. I will show you that quickly afterwards. So in this case, an example of a package revision. So we have here the spec file from beforehand, the version of the application, the build requires GCC and the library, and then we realize we need a superfix. So we add a patch superfix here, and then the revision gets increased, and you have a new revision of the package afterwards. Okay, so as I said, the build systems, many distributions have their own build systems because they all invented the wheel. But I want to talk about the Open Build Server, which is from SUSE, because it can spin many wheels. So why is this? With the Open Build Server, you can build packages for different architectures. You can build packages for different distribution versions, like OpenSUSE Tumbleweed, OpenSUSE Leap. And you can build it for different distributions. So this is really nice. So you have your software. You can build it in the Open Build service, and you can build it for OpenSUSE and for Fedora, for example. And then you don't have to integrate it 2 times in the Fedora build service and in the OpenSUSE build service, but just once. Okay, some keywords for the Open Build service. So you have a package, which is your program or your library. We talked about this. Then you have a project, which is a set of packages, which could be, for example, KDE is a project in an Open Build service, which has like 30 maybe packages. And then you have a repository that is against which the packages are built. This can be OpenSUSE Leap, OpenSUSE Tumbleweed, or Fedora 26, or whatever. So that means basically, if you have a build requires, then that installs you have a build requires for some library, then it will install the library from OpenSUSE Leap that OpenSUSE Leap uses. And if you build the same package against the repository Tumbleweed, then it will most probably use a library in a newer version to compile it against. Yeah? Okay. Let's do a short demo. Can you do this? Yes, that's good. Okay, yeah, you don't see that so good. That's a pity. Right now. Okay, that's better. Okay, so this is the build server, but build.opensuse.org. This is a web interface. So you can see here the system status. So we have currently 942 build hosts that are compiling some packages out of more than 1,000. And you can see you have like 44,000 projects, 411,000 packages, and 48,000 confirmed developers which are collaborating in this. So it's a really big project. So I'm logged in here with my user, and if you go to the home project, then I added my own hello world programmed in C, which has a source code, which has a fix and patch the changes file, because I needed several revisions to actually get this built correctly. So you can see it down here. It's revision 4 and the spec file. And here on the right hand side, you see the different repositories you're building against. So you see OpenSUSE Leap, and you see OpenSUSE Factory. That is the one where the rolling release is created from. And then you can see here when it shows succeeded, that means the package got built. And here you have, for example, blocked, which means some packages that are needed for the base system or from the build requires of this specific package are not compiled at the moment, and so we have to wait. And if we wait long enough, then it gets scheduled. That means it's in a queue for the build servers to get then built in a virtual machine. So what I wanted to show you is, if we go here and we say now, okay, but we want to build this also against a different distribution. So you go to repositories and add repository, and then you can find here a lot of repositories, and we can, for example, add Fedora 26. And if we go back, we see that Fedora 26 shows up here. Here it doesn't show up yet because it needs some time to update. So it shows up here, and it will get scheduled, and it will get built. It will get built, and hopefully it will succeed. And if it not succeed, you can pin on it, you can click on it, and then you will see some log what's actually doing and why the build has failed. On the other hand, I have, for example, here I did a branch from the Nextcloud package from the official repositories from OpenSUSE. This is in my home repository. I need to click here. And you can see this here. Well, this links to this project and this package, right? And then you have a link div, which shows you what I changed. So I put in some new requirement for the version of PHP 5 because it was not working for me. And then I could, if I think this is an intelligent change, I want to merge back to the main package, and so I don't have to keep it around in my home project. I can submit the package, and I can write some description what I want to do, and then it would get, the maintainer of the package would get a service request, and then he could have a look if he thinks it's intelligent what I want to change in the package, and then he can accept, or he can say no, that's not the way you should do it. Okay. So there's another tool which is called Kiva, which has this nice Kiva logo down there, which is a command line tool to actually build the ISO image. So it has like an XML file where it describes how the file system is organized, and also has a list of packages to install the image. And it supports many formats, not only ISO to burn a CD or USB stick, but you can also use, for example, Amazon EC-DOS file format. So this could be used to easily if you, for example, have your application running in an Amazon virtual machine environment, then you could update your application in the open build service, and then you rebuild this image, and then you can deploy the image easily and show if everything works as you supposed it to work. Okay. Okay, let's talk about testing a distribution. So as I said beforehand, a distribution is about applications and not about code. So there are lots of tools for testing code. like unit tests and Google tests and whatsoever. But there are not so many, or there are no tools for testing desktop applications. The only tool I know of is this Android Monkey, I think it's called, which just randomly clicks on the touch screen and logs where he clicks, and then you leave it running for one night, and then the next day it crashed, and then you can say, okay, it crashed, but you can't really define a test vector. You say, I want to test this and this and this. It's just random. So the thing is, for a Linux distribution, the test vector is actually huge because you have thousands of packages, you have a lot of programs, you have different configurations if you install it with this file system, with, I don't know, maybe Btrfs file system or XFS file system, and so on. So it's not easy to test this. Apart from this, if you have a rolling release, that moves really fast. So we can have here like an example of a quiet week of OpenSUSE tumbleweeds. So we release 3 updates in 1 week, which updates like 140 something packages, deletes packages, removes packages, whatsoever. You get a new kernel, so it's unable to test this by hand because three updates a week. Work week has 5 days. You will have 1 day at last to test everything and then say, okay, we release the update. So this is not possible. So that's why there's a tool or program, well, it's a framework, a big monster, which is called OpenQA for automated application testing, which is around since 2009, and which is used by SUSE, and it's used by Red Hat as well for Fedora. So that's really nice. So we don't have this situation like with the build servers, build systems, where every vendor has its own one, but Red Hat decided that this OpenQA is a good approach, and they contributed to the system and use it for Fedora. So that's really nice. So you can do testing on the GUI and on the console, and it's open source, so everybody can use it, can download it, can add tests, can test his own application if he wants, and can do what he wants with it. So how does it work? Basically, it works that the distribution image gets connected, started in a virtual machine, and then you connect via VNC to it, and you behave like a normal user. So you don't have any change to the code base. It is the image, like you'll later ship it if everything goes fine. So then you compare. So you click and you say maybe open Firefox, and then you define some needles, which are some parts. I will show this in a moment on the screen. And you have an image database, and you say, okay, if I open Firefox, then it should look like this, or like this. And if you find a match, then you say, okay, this test passed. Next step. And if not, then you get a warning that the test fails. Apart from that, it can compare the serial console output as well. So you type some command on the serial console, and then write some output to a serial console which is connected to OpenQA, which runs like in the host of the and OpenQA can then check if the output is what was expected. Okay. So we have quite some time. So I will show you a small demo about this. So here you can see OpenQA, how it tests OpenSUSE. So we have different distribution versions. We have OpenSUSE Tumbleweed. We have OpenSUSE Tumbleweed for ARM64, for PowerPC. Here we have Leap updates for OpenSUSE Leap, and so on. And then you can see this is the date of the build. This is, as you know, the Tumbleweed is a rolling release. So the build is from yesterday, about 17 hours ago. And it has passed 12 tests. 102 tests are still executing to see if they work. And here you see the small red one is 3 tests fail. So this image has some problems, and then you can look into the problems and see what's happening. So I prepared some failing tests to show you how this works. As you can see, can you read this more or less? Yeah. You can see you have different tests, which is like test installation, which has different sub-steps. It's all green, so that's really nice. And so you install the system, you update the system, you do some console tests here, and then you do some graphical tests, and you start Kate and Firefox and Chromium and so on and so forth. And then you see here GNU Cache, which actually fails. Okay, so you can see here, this is marked red. That means here's where the actual failure happens. But we might maybe start here. If it wants, yes. So you can see here, we have a needle, which is 100%. So this is, okay, let's start like this. So you can go the slider. So on the left-hand side, you see the needle, what it expects. And on the right-hand side, what you actually see in the virtual machine. And you can see it's 100%. So this application launcher from KDE is working fine, perfect. So we go to the next one. So we type in GNU Cache, and then we wait. And we wait to see if GNU Cache opens up. And then it still hasn't opened up, and then OpenQA say this test fails. Because if we check some of the needles here, you see that maybe they expect down here, like a window with GNU Cache, which doesn't show up because there's some error. So this this makes it now easy to try this offline, let's say, and see why GNU Cache doesn't start. Yeah. Another example is here, which is also KDE. Where I wanted to start here, I think. Hola. Okay. Oh, can you see this? You can't see anything, right? No, you can't see anything. Okay, then I can't show you this. Actually, it executes a command, and then it makes an echo of some random string, which is just the identifier and the return value of the command, to TTY 0, which is connected to the OpenQA framework, which OpenQA then can check if the return value of the program is the expected one. In this case, it is the expected one, but then something strange happened, that you had some could not sync environment to dbus, which is really bad. And in the end, we see something like this. So they should OpenQA expects the desktop, but you see some really screwed up screen for loading the X system. So yeah. Okay, so I provide some links. So if you are a student, maybe you're interested in Google Summer of Code, there's a homepage 101.opensuse.org where there are some projects to apply for. Open Build Server, OpenQA are both are open source, so you can collaborate, or you can install it on in your corporate network if you want to do something that no one should see. There are many more projects on the OpenSUSE GitHub. If you're interested and want to try OpenSUSE, there's the OpenSUSE.org landing page. And if you are looking for a job, SUSE is searching engineers which work on open source or like to work on open source. Yeah, just have a look if there's something for you. Okay, that's all I have. And thank you very much. And any questions? Yes.
Topic. On these screenshots, did someone sit there and click on buttons and record it or that? Or is or is that automated?
The clicking is automated.
I mean, creating those screens.
Yes, actually.
We compare against. Is that automated?
Yes, it's automated. They take a screenshot every, I don't know how many seconds. Actually, that's something I wanted to show you. I forgot. You can go here to logs and assets. And there are some serial output and some JSON file with all the configuration. And you have a video where you can actually see what is done in the OpenQA test. Unfortunately, it's difficult to see. But you can see, this is, I mean, every test gets recorded so that you afterwards can see what actually has been done and where it fails.
But do you prepare the test, or the test is also automated and you say it's okay or not? I'm not sure if I'm explaining very well.
The tests are open source, which are in a repository, which is written in Python. And these tests, I think it's the OpenQA team in SUSE which integrates them in the test environment. But I mean, if you have, for example, your own application, your desktop application, and you want to test this application, you can install OpenQA on in your company servers, and you can write your own tests, and you can test your application there. Did I explain? Yeah.
Do these screenshot tests break more often than you wish?
Sorry?
Do they break often, these screenshot tests, or they are pretty stable?
They break often. Actually, they break often because yeah, that's a bit. There's no really, or I don't know of any intelligent way of fixing this. But when you see here, for example, you have like 1, 2, 3, like 5 or more different screenshots of different version of. If you have a new version of KDE, then maybe the window looks a bit different, or maybe it's not on the same in the same corner and whatsoever. Then the test, many times the test fails just because of some, not because actually the program fails, but because the screenshot is not correct, but the test should have worked. But I mean, they use this OpenCV plugin to do this matching. So
is there necessarily a human validating the build, or does a human being need to come here to say, okay, this is actually correct, or do you say you compare different screens and you say, okay, this build is actually green? How do you solve these failing builds?
yeah, actually, there's the people from the QA department. Yeah, and you review, and if they see that that's actually correct, then they will add this screenshot to the database. So the next time it will pass.
So some years ago, there was a hype on unikernels. So what do you think about unikernels compared to the Linux kernels?
What are unikernels?
Unikernels, so they are like a specialized operating system without all the...
Microkernel, yeah, you mean like for IoT or something like this?
Well, or yeah, go ahead.
I mean, for IoT, for
Services.
servers.
Yeah.
So if you're going to run a server that does X, I might get benefits from having an OS that is specialized in doing X and doesn't have anything else. Kind of.
Okay.
99% of things you don't use. Right? When, I mean, I'm not talking about desktop.
Okay, yeah, it's okay.
I'm going to run containers, let's say, a simple example, right?
Okay, I mean, what Linux has, it has all these kernel modules. So the configuration of the kernel of OpenSUSE, I suppose that Fedora and all the others, they do it the same. They actually build everything that you can build as a module. It's built as a module, and then it gets just loaded the stuff that you really need. Yeah?
How do you specify what you need? How do you specify what
The firmware, the BIOS normally has some tables which is called CPI tables. They describe all the hardware that's inside your system, and then Linux can identify this, can read the CPI tables, and then knows which drivers it has to load.
Okay. And how about the rest of the node drivers?
You mean memory management or?
No. Memory measuring, you need obviously stuff like that, but kind of everything else that is in distribution, how do you remove that? Firefox. I mean,
Okay, yeah.
An example, but
Okay, I mean, of course, yeah. I mean, OpenSUSE or SUSE Linux Enterprise is. I mean, we normally don't do a special version of our system for one customer, because this is a maintenance, an explosion of maintenance. If you have 1,000 customers and you have 1,000 different distributions, if you want to do this yourself, you can do this with the Kiva tool. So with the Kiva tool, you can put in the list of the packages you want to install. You can put in just the packages you need. And then you'd create an image, and then you can burn it on a USB stick or put it on Amazon EC2, and you're fine. So you can do this, but it's not something that we would support you.
yeah, no, of course. I was just building on his question about the
Yeah, I think this thing will apply if you are deploying a custom container with the operating system with a specific product in a specific server or something. Yeah.
talking a simple example, let's say that I'm going to run Docker containers on a server, right?
Yeah.
I need Docker engine, memory management, CPU, IO, and quickly almost nothing else.
Yeah, network.
Network. I mean,
Yeah, I know.
5 things. 10.
Any more questions, comments? Yes, please.
I've never used OpenSUSE, but what do you think it does better than other distribution? What's the strong point?
What's the strong point of OpenSUSE? So if you're a lazy guy like me, then you have, for example, Yast. I don't know if you heard of Yast. It's I don't know if I should show you. No, I won't show you, because it's like a configuration tool where you can configure most of the stuff that you need, like the IP tables or NF tables for your firewall, or if you want to start an NFS server, or if you want to start an HTTP server or whatsoever, you can do that easily through this tool, which is
Like Ansible?
Hmm?
Kind of Ansible?
I don't know Ansible. Sorry. So I think this is one of the good things. And the other thing, what I'm really surprised of, is the rolling release. So this laptop uses a rolling release, and I only had once problems after updating, because I did the update wrong in the end. So this is really stable, and you always have like the newest software. So.
And who updates, like, which is the latest package? And the rolling release, is that the package provider, package maintainer, or?
It's an upstream package. So this is so the OpenSUSE. There's in the Open Build service. There's this project OpenSUSE Factory, which is which has all the upstream packages, and it builds them, and they build them, and when they finish the build of all packages, they take a snapshot and that passes to OpenQA, and if it passes all the tests, then it gets distributed. So it's an automated process. I mean, you have all these what we talked before. I mean, if there is the window, the Firefox opens, but it looks different because it's a new version, then it fails, then you have to fix this. But in general, all the process is automated.
The rolling releases, I mean, if you know, how do they handle like really major changes? So, for example, if glibc changes in a very major way, and that potentially can break hundreds of packages. So how do they handle the release very basic packages that everybody
normally at SUSE we have, for example, in SUSE Linux Enterprise, in our enterprise product, we have SUSE Linux Enterprise 12, which is around for many years, which has GCC 4.8, and which has, I don't know which libc version, a really old one, which just get maintained. And then if you want, and then you get service packs, which always use the same base system. You don't change this because it's like a nightmare. And now, when you do a new version like SUSE Linux Enterprise 15, let's say, yeah, then you update all this base stuff. But normally you don't touch this. You touch this in the rolling release, but in a stable release you keep it around and until you do really a major update. I don't know how they do, how other distributions do this. I don't know. I can't tell you.
No, Red Hat does the same.
That's the same, right?
Yeah. It's just more interesting in the rolling scenario, because then what do you do?
Yeah, and well, in the rolling scenario, at least, I mean, we do these tests to see that everything's working. So we build all the packages. So that's why beforehand we saw this. Here we saw all these block packages. Eppa. That was not what I wanted to show. You can see here, right? Fedora 26 finished its build. So you could go here. I know this is that was wrong. You could go here, go to the download directory, and if you use this URL, you could then add this with yum add repository or whatever, and then install the project. Sorry. Yeah, so we rebuild the packages all the time, and so we get all the build failures by rebuilding, right? And then if there is any breakage in the applications, we get this with OpenQA. I mean, there can be problems. There can be problems. I had once a problem with UDEV because there was some program for blind people who have a Braille interface, which uses a UDEV rule, which also uses serial adapters for USB. So I updated the system and I plugged in my USB serial adapter and it didn't show up because there was some trouble. Okay, thank you very much. I hope it was interesting for you.